Welcome to today's webinar. My name is Sharon Fitzpatrick, and I will be your co-host for today's webinar. Joining me is Emily Tipping, the editorial director for Recreation Management magazine, and Emma Jorgensen and Jack Stanley from Neptune Benson. As we go through the presentation, if you have questions, as we just found out, we're happy to answer the questions, share them with the presenters, and everything else you might need. So we also want to let you know that there are some handouts that we've included, and you can go to the handouts tab on your dashboard and download them. As one of the handouts that we have, we've included a set of today's slides in case you'd like to print it and take notes. So at this time, what I'd like to do is turn it over to Emily Tipping, the editorial director for Recreation Management. Emily, welcome.
Hi there, everybody, and welcome to our webinar today. I am Emily Tipping with Recreation Management. We are a publication going to 55,000 subscribers covering recreation, sports, and fitness facility management. If you are not already a subscriber, I surely encourage you to become one. You can go to www.recmanagement.com and sign yourself up for a subscription. Today, we are going to be talking about regenerative media filters. As you probably know, there's constant innovation going on in the aquatics industry. Manufacturers are constantly coming up with better ways to make operations work. And so RMF filters can save resources at your pool, and they can save you operating costs, and we're going to find out more about how they do that today. So without further ado, I would like to turn things over to our presenters, and I hope we all learned something.
Great, thanks very much, Emily. Before we hand this off to Emmett and Jack, I'd like to kind of launch a poll and really understand a little bit about who you are and what type of filtration system you currently use. So I'm going to launch a poll right now. You should start to see it. There are multiple choices that you can choose from, and I'm really curious to kind of see where people are. Jack and Emmett, where do you think people are currently in what type of filtration system they're using?
I would say most of the responses you're going to get on that question would probably be sand, horizontal or vertical steel, horizontal or vertical fiberglass. While there are cartridge, vac sand, vac DE options still out there, I would say sand would be the primary response you're going to get here.
Well, you know what? I'm going to close the poll and actually share the results. And as you can see, 91% said sand. So you were right on there. So I think that that's something that we're going to talk about today, and you're going to educate us. So at this time, what I'm going to do is turn the platform over to Jack and Emmett.
Welcome, everybody. Welcome to our webinar here. We're coming to you from sunny Rhode Island. We haven't been able to say that, sunny and warm Rhode Island, in the same sentence for, I don't know, all summer, but we can say it now. But we're coming to you from Rhode Island, and we're here to talk about regenerative media filtration. Now, what we're going to do as an objective today is we're going to review the technology of regenerative media filtration and how it is surpassing sand filters in the use in today's aquatics facilities. We're going to go through an overview of the product, how it works, how it performs compared to sand filtration, and how it compares technically in terms of features and benefits, as well as a cost comparison to give you some rough idea as to what the difference in cost would be between sand and regen, and how the benefits of the regen filter could quickly make up the cost delta between the two products. This slide should really read your goal, I think. Your goal as an aquatics facility operator is to operate an efficient facility while still providing the exceptional experience for your patrons, your swimmers. It can be difficult to achieve, but the balance is there and it can be achieved. Ultimately, the goal is to improve efficiency of your operation, reduce your costs, your overhead, and provide that excellent experience for your swimmers and your patrons. Now, the progress of regen filtration. This is interesting because I think I was around when it really rebirthed. and I don't want to say when it was born, because regen filtration has been around for 35, maybe even 40 years. It was just a sleeping giant inside of a closet. In the past, it was mostly sand. We had open pit DE as well. I've been in the industry for 20 years, and I have to say, since I started, open pit DE had already started fading out. But sand was the primary filtration method for commercial swimming pools. Today, with water usage being what it is, you go all over the country and you see how there are scarce water supplies. Big facilities, not just swimming pools, but all types of recreational water facilities are being compromised in how they can use water. So presently, RMF, regenerative media, is taking over the market over sand. While sand is still there, RMF is taking the lead. We get calls in this office all the time from designers, owners, and even contractors, and I would say that 80% of those calls are asking for budgetary analysis involving regen filtration, which brings us to the future. It's my opinion, and the opinion of the veterans in this office that have been working in this business for a long time, we are heading toward RMF, where sand on these larger bodies of water could very well be a thing of the past. Water filtration has been typically, for commercial pools, has been sand, vacuum DE, cartridge, or regen. Improvements in filtration technology and equipment are reducing water and energy consumption, because that's the way our industry is going. The current technology for regen filtration provides reduced water consumption. There's no doubt about it. We've got the facts and figures to prove these filters will save water, both on the makeup end and on the wastewater disposal end. A finer filtration particle. We will filter down to a single micron with a regen filter. That's unheard of in a sand system where you're filtering down to around 20. The energy savings and reduced chemical cost, again, these are proven benefits of this type of technology. Regen media filters are leading the way in commercial filtration, and again, it is the way of the future. Regenerative media filter overview. Regenerative media filters are filters that utilize surface area rather than bed depth to provide filtration for a large body of water. They generally consist of a vertical tank. That tank could be stainless steel or lined carbon steel. And on top of the tank is a stainless steel tube sheet with hundreds of what we call filter tube elements or septums, which hang from the sheet and create a large surface area for filtration. These filter tubes are coated with a fine media called perlite. Perlite is a mined volcanic byproduct, and we'll get into a little bit more about what exactly it is as we proceed. But the elements are coated with this material, and as the filter is filtering, the particulates are getting trapped on the surface of those tube elements that are coated with the perlite. It offers several distinct advantages over traditional sand filters. One, regenerative media filters will significantly reduce consumption of your water by eliminating the need for backwashing. If you've got a sand filter at your facility now, and let's say it's a 45 by 75 lap pool with a flow rate of about 500 gallons per minute. I'm just picking up what I call a cookie cutter pool. You could be backwashing 2, maybe 3 times a week. Even if you're backwashing once a week, let's say you're sending 3,000 gallons of water to waste every week. Eliminating that backwashing reduces chemical costs, reduces the need for makeup water, and it reduces the need to heat that makeup water. The vertical design of this filter saves space. Because this filter does not work under the premise of bed depth, if you're designing a new mechanical room for a new facility, sand filters take up a lot of space. This type of filtration, because you're able to filter so much in such a confined space, will allow you to have a smaller mechanical room. When I am approached by an architect to talk about a regen comparison on price, I often ask them, please, can we factor in the cost of building materials to house a larger mechanical system? That is definite money that comes into play when you're comparing the two. The RMF filters remove particles 30 times smaller than traditional sand filters, again, down to a single micron. We call the water with regen filtration gin clear. We don't use crystal clear here. We use gin clear. That's a lot clearer than crystal.
Thank you. Before we go on, Jack, I think I'd like to really ask a question of our audience to find out how old their filtration system is. And I'm curious, what do you think that we're going to find? Are people really buying it and keeping it there forever, or are they actually replacing them every 5 years?
Well, I was right on the first poll question. So if I'm right on this poll question, I hope I get a prize.
Winner, winner, chicken dinner.
I'm going to say that your answers are going to be between 10 and 15 years old. That's what they're working with for their current filtration system.
And you know what? I'm going to tell you that, gosh, the chicken dinner is on the way to you, because if you look at the results, we really overwhelmingly have over 10 years old. You're pretty much spot on. So at this point, I'm going to go back to you and let you continue with your presentation. Thank you.
I've been doing this way too long. Wow, I wish I could pick the number like that. How do RMFs work? How do regenerative media filters work? Well, inside the vertical steel tank, your tube elements, or your septums that we spoke of earlier, which are made up of T316 stainless steel coil wrapped in a high-strength polyester weave. Now, depending on the width of the tank will determine how many elements are in the tank. We've got several different sizes of regen filters, and all companies that have this type of filtration certainly offer more than one size. So the number of these steel coil wrapped elements will depend on how wide the filter is. Each tube element is coated with the perlite media. Again, the perlite being a mined volcanic byproduct, it's product that's readily available from just about anywhere where you can buy pool supplies or any type of landscape or land materials type of store. It's not an exclusive product by any means. But the perlite media does hold itself in suspension longer. You'll see why that's important. Holds itself in suspension longer than DE. You'll see why that's very important. But anyway, the elements gain an 1/8" average media coating around each tube. So the coated elements combined serves as your surface area. That is your filtration surface area, which is 9 to 12 times the filter area of an equivalent sand filter. So these types of filters have hundreds and hundreds of tubes hanging from the top of the tube sheet, coated with the media that catch the dirt as the filtering process takes place. Here's your filter tube with nothing on it, and the animation you just saw shows how the material coats a layer of perlite media around each tube element.
So we have a couple of questions, Jack, before we move on. So Ben wants to know, is the 1 micron filtration with DE certified? Is that the average or the lowest?
Well, that's what we advertise, because we had tests done, independent tests and studies done to see, to confirm that finding was accurate. That's the lowest. I mean, I don't think we can get any lower than that, but 1 micron is the certified lowest that we've achieved with our outside testing.
He also has a follow-up question. Can regular DE be used in this filter?
Yes. Regen filtration can use DE, and there are products that do use DE. Perlite is another option. We consider it a better option because it's a non-hazardous material. It's safe to work with. It's readily available. It's safe to dispose of. So it makes sense to go that direction in our opinion. But the answer to your question is yes. Regular DE can be used in a regen media filter. It does not have to be perlite.
Perfect. Back to you.
What you see here is a cross section which will show how the filter filters. So what you're going to have is you're going to follow the red line, and from the pool, from the surge tank, from the balance tank, whatever the case may be, you're going to have your water coming in through the strainer, just like with a regular sand filter. coming out of the strainer through the pump, and instead of going into the top of the filter like you have with a sand filter, the water is going into the bottom of the filter, and those coated elements are capturing the dirt, the particulates, before the water leaves the filter out the top and goes back to the pool. Again, following the red line, the water goes into the bottom, filters through the septums, out the top, back to the pool. On the way back to the pool is where it's heated, treated, UV, whatever the case may be on your return line. Here you see an animation of the dirt being captured by the coated elements. The perlite, again, forming the 1/8-inch layer, it's already there. As the water is being filtered, the particulates are captured on the outer surface of the perlite media. There is your filtering taking place. Now, a regenerative media filter can be automatic. It can bump automatically, or it can produce the bumping action manually. We call that regeneration. Now, when the filter bumps and when the filter removes the media and the particulates into suspension, most of the time, most operators like to be in the mechanical room and press a button. It is really a button. Now, when the button is pressed, or when it's set automatically to do this once a day, what will happen will be, you're going to get the effluent valve on the top of the filter heading to the return to the pool. You're going to have that close. Then you're going to have the pre-coat valve on the pre-coat line open. You're going to have the pump shut off, and you're going to have a bumping action take place via the pneumatic tire on the top of the filter. When this happens, everything inside of the filter will suspend into a cloud, and now you have your elements that are bare. There's no more media on the elements. Everything, the media and the particulates have suspended themselves. Let me also note that the valve on the effluent side of the strainer is a check valve. So what's about to happen will keep the loop. It will not allow water to go back to the pool. The pump will come back on, and you're going to start a regeneration situation. Once the bumping takes place and the pump comes back on, you're going to create a loop. And that loop is going to place. The air is quickly exhausted from the bump tire, and everything that's captured on those tubes goes into suspension. The bump tire reinflates, and the expanded flex tubes cause the perlite and the particulates to release. Next. What happens is the perlite media repositions itself. So you're taking the media and the particulates, and you're moving everything around inside of the filter. It's well known that a dirty filter can filter better than a clean filter, and what we're doing here is we're prolonging the life of the cycle. In other words, we're taking all of that media, we're taking all of that dirt, we're juggling it all around, we're repositioning it, and exposing fresh media surface to the filtration process.
Are we dealing with year-round facilities or seasonal? And what does the majority of our audience work on? So what do you think?
My opinion is that most of the attendees on this call are working in operating year-round facilities.
Well, I would say right now we've got about 48% of our audience has voted, and once again, you are right on. And I will close it and share the result. There you go. You are correct. 86% are year-round and 14% are seasonal. Back to you.
Okay, so now we're going to talk about the water savings. The bump and regeneration process plays a significant role in the reducing the amount of water that's used. Now, when you bump and you recoat, you're not sending any water to backwash. You're just bumping and recoating the filter, and there is no water that leaves during a bumping process. When you have to drain a regenerative media filter, it is not a backwash process. It is a draining process. You're doing nothing more than draining the filter after the bumping has taken place. So you're sending very, very little water to waste. Let's use that 500 gallon per minute flow rate as an example. That flow rate would require a filter that would have 381 gallons of water in it. When it's time to remove the media and recharge it with new media via the vacuum unit, which is a very simple process, when it's time for that to happen, you're just draining the contents of the filter to waste twice. So instead of our example of backwashing once or twice a week between 3,000 and 5,000 gallons, depending on how many times you're backwashing, once a month, you could be draining 381 gallons times 2. We would recommend a double flush every time you drain a regen filter. So do the math in terms of the water usage and the costs associated with thousands of gallons versus roughly around 750 to 800 gallons going to waste. It will total up to 90% less water used, and that will especially amplify itself on a 12-month year-round facility. Energy savings. How does the regen filter save energy? Well, one of the things that we've noticed, again, we get calls a lot from designers, architects, consultants that are looking to size this type of equipment and put together a package of equipment recommendations. You've got less head loss, or less head pressure, I should say, through a regen filter than you do with sand. And I can tell you, when you're sizing a pump for a mechanical system, you can actually go down a size when you have less head pressure to deal with. Now, over a 12-month period of time, running a 20 horsepower pump instead of a 25 horsepower pump, that can equate to quite a bit of money saved in the energy department. And then you have the heating. When you're backwashing water, when you're backwashing thousands of gallons of water out of a mechanical room system, you are sending water to waste that needs to be replenished. And when that water needs to be replenished, it needs to be reheated, hence the heating costs that are associated with sand filtration. And you don't have that type of thing, or very little of it, I should say, associated with regen filtration. Now, this graph shows the cycle of a sand filter, which is highlighted in yellow, and underneath you see the cycle of an RMF filter, which is highlighted by a blue line. So as the pump is working and working and working to reach the point where it's time to backwash, as you'll see, there's a lot of stress and strain and work going on to get to the point where your sand filter needs to be backwashed. Now look how the pump is working when you're bumping daily. You're bumping and releasing daily the media and the particulates into suspension. That pump is not working nearly as hard as it would have to work with a sand filter. It's just a smoother operation, and there's money to be saved in how the pump operates when you're using an RMF filter in this manner. And when I say this manner, I mean bumping and recoating daily, not weekly, daily. And this slide shows, I use the example of 25 to 20. I should have used 40 to 30 to be consistent. But a 1,500 gallon per minute flow rate for a sand filter system, that's a 4-tank system that you see there that we have highlighted for a sand filter, versus a single 49-inch regen filter. You're literally going down a pump size. Your TDH is less because there's less restriction going through the filter. And again, this is proven data. The pump can be smaller with a regen filter. Now, what we recommend when we're sizing a regen system is we're big fans of VFDs, variable frequency drives. And I have to think that everyone on this call, or at least 95% of the folks on this call, know what a VFD is. They are more popular than ever, not just with regen, but with sand as well. We're seeing them on designs 90% of the time because they've come way down in price, and the benefits of using the VFD are amplified. They are amplified when you use them in conjunction with a regen media filter. Now again, we get requests all the time to run the numbers, and when we're provided the energy costs and the water costs and all that type of thing, one of the areas we focus on is how much will a facility save when they use a VFD in conjunction with a regen filter. And the numbers are staggering in terms of money saved during the 12-month period when you're coupling the regen filter with the VFD. Now this example has a sand filter with a standard motor starter. That's a dinosaur. I mean, that's something, at least we're seeing a sand filter with a VFD. But when you're comparing the two and you couple a VFD with a regen filter, the savings over the 12-month period, it's really something to look at. And again, it's one of the reasons why, yes, paying more up front, it kind of stinks in the beginning, but 12-month facility, go 3-4 years and have this filter pay for itself, you end up with an annuity in your mechanical room. Chemical costs. You're using pelletized chlorine. You might be using gas chlorine. I don't know. I'm primarily in the Northeast and Mid-Atlantic. I don't do much out toward the west or the middle of the country, but my guess is the only place you're using gas chlorine is in Canada. I could be wrong, but you've got pelletized, you've got gas, you've got liquid chlorine, you've got acid and CO2 for pH control. You might have bromine, but the point is, when you're not sending that water to waste and you're not having to replenish it, you can count on your chemical costs going down significantly with a regen media filter. Now, we touched on space savings a little while ago. What you see here is an illustration of a footprint of a mechanical room that would require sand filtration versus regen filtration. And where this becomes a big deal is if it's a new build and you're talking to an architect, again, look at the space that you don't have to take up with a regen filter, even taking into consideration the swing of the head. Now, there are times where the head on a regen filter is lifted for inspection, and it's not a yearly thing. It's not a bi-yearly thing. It could be once every 5 years. But even taking into consideration the swing of the head when you're removing it off a regen filter, it's taking up a fraction of the space that you would take up with a traditional sand system. And again, what you're seeing here is an application for a 1,500 gallon per minute flow rate. You've got an easier install with the regen filter, far less plumbing, less ventilation needed. You're going to find yourself, if it's an existing room where you're doing a retrofit, you've just found a lot more room to store maybe some of your deck products and deck goods. And it is an easier retrofit than plumbing in new sand filters. It really is. And we got that comment back time and time again from contractors that have installed these filters. This was an example of a facility that took advantage of the regen filtration after the fact. And the reason being, it really wasn't on the hit parade in terms of popularity when this particular facility was built. But look at the space they've saved and the room they've gained by taking out all of those sand filter vessels and replacing them with 2 regen sand media filters. I'm sorry. A lot of room they found as a result of making the switch.
How often do you backwash your filters? Once a week, twice a week, or more than twice a week? Jack, tell me, what is kind of the industry standard? What do you recommend?
I'm going to say twice a week is going to be your most popular answer.
Great. I'm going to close the poll and share the results and say no chicken dinner for you this time. It's once a week was the favorite answer. So why don't you tell us whether or not that's acceptable or what it should be? Back to you.
You've got very clean people out west. I don't know. Most of the clients I've talked to, most of them really do say they backwash. If it's a 45 by 75 indoor pool with heavy usage, I'm hearing twice a week. But look, even if it is once a week, the savings is still significant, which segues us right into this next slide. What you see here is a 10-year savings forecast. This is something that we put together, I want to say about 6-7 years ago, when we were asked, justify us going this direction. When you're spending what could be double the cost of a sand filter, you've got to show reasons why or how the filter will pay for itself. And what we do is we take into account the cost of water per 1,000 gallons in a particular region, the cost per 1,000 gallons of backwash water, the cost of chemicals, the costs associated with construction if it is a new build, and the costs associated with heating the water. And what we get, now I'm not saying we get this kind of a spread every time, this kind of an analysis. You see, what you're seeing here is about just under a 2-year payback for that filter to pay for itself. I mean, we've got facilities that are outdoor facilities here in the Northeast that are only open 3 months out of the year. So they're not seeing the payback nearly as quickly as what you're seeing here. But the other advantages are being experienced. The finer filtration is the biggest reason. The lack of water usage, it's still a factor, even though you're only open 3 months out of the year. We've got areas of New England where the water restrictions are so tight. I mean, they're lucky if they can backwash once a season, never mind once a week. But what you see here is a payback analysis that we would provide if we were asked to justify the costs associated with a regen versus a sand filter system. Water quality, it's got to be it's got to be in the top 3. Water quality is important to everyone on this call. A micron, how small is a micron? This gives you a bit of a frame of reference of what size a micron is. Paperclip versus human hair versus a pollen grade versus a red blood cell. What we have here is a system that will filter down to the smallest particle possible, and your water quality will be absolutely second to none. And we've got reference after reference, as I'm sure all companies that provide RMF filtration should have reference after reference that this is the way to go in terms of best water quality. Now, there's new technology associated with the new technology. Touchscreen, interactive touchscreen, LCD screens have replaced push button. Remote monitoring is all the craze, not just in the control for the filter, but also your chemical controllers. I mean, these have gotten pretty fancy where they can do data logging and exporting information. And also, one of the big features or benefits that we've seen, well, I don't want to say it's a benefit, but it's a feature that we've been asked about over and over again, is integrating other systems into the panel. You've got your UV and you've got your variable frequency drive that can be tied into these newer control panels. So you're literally controlling the pool. You've got everything right there at the palm of your hands to control and monitor your swimming pool. So let's summarize the Fab 5. 90% less total water usage, 50% less energy used, 30% less fuel and chemicals used, 75% less space, and 95% less particulates than you get with sand filtration.
That sums it up pretty well.
Yes, it does. Thank you both so much. I think we've really learned a lot about how to make waves in aquatic facilities. So at this time, what I'd like to do is open it up to questions. And just a friendly reminder that to submit your question or comment, use the question tab on your dashboard. And we do have a couple of questions that we've gotten in. So do RMFs increase total dissolved solids or TDS? And if so, how is this managed, and then does it affect the water savings?
Well, TDS is a question we're asked all the time. And yes, you have to take into account there needs to be replenished fresh water in a swimming pool. There's no debating that. But even with that 10% is what we use as our benchmark. Even with that factored in, where you have to, let's say, I'm going to give you a few examples. Crack the pre-coat vent line. There's a ball valve on it that will allow water to bleed. There's a sample line on the chemical feeder that some facilities keep open and allow water to bleed. You've got normal pool maintenance where you're draining a pool for maintenance, for tile cleaning or what have you. And we also, our particular company has a kit that we can include that allows for draining to take place periodically on the filter, because TDS is a concern. You do want fresh water in the pool. But the facilities that are taking one of these suggestions in draining, or what we'll call dripping water out very slowly, even taking into account that type of water evacuation, you're still saving money, you're still paying yourself back in a very, very attractive amount of time, and you're still getting that finer filtration cycle.
Great information. Can you provide any examples of facilities using RMFs?
Oh my goodness, we'd be on here for 2 hours. Yes, I could. Anybody that would want references in any part of the country, we keep very, very detailed records. If you want references for facilities that are using them. And if you want to talk to the people that are using them, actually the hands-on folks that have had experience with the Regen product, you can feel free to reach out to Neptune Benson, and the right person that covers that region will get you the information you need so you can hear all the good news firsthand.
Can you give us an example of the types of facilities that might be using RMFs?
Sure. Water parks could be our biggest customer. I mean, we've seen indoor water parks spring up all over the world, all over the country here. We've got Great Wolf, you've got Cocoa Bay. There's so many different franchises out there, and most, if not all of them, have one way or another, on one attraction or another, Regen filtration. Recreational departments, municipal pools that have family aquatic centers, very popular with Regen filtration, and that includes outdoor facilities. Your YMCAs and boys clubs have gone down the road of Regen filtration. One of our biggest newfound customers has been the swim school arena. Swim schools are popping up everywhere. I mean, either franchise or private mom and pop operations, and Regen has become more and more popular with these schools.
Great. What's the cost difference between sand and a regenerative media filter?
Well, when you have a Regen filter, you're going to get an automated filter. Now, sand filters can come with automation, or they can come with a manual backwashing linkage or a series of valves to allow the backwash. So that question, it could vary. If you're comparing it to an automatic sand filter, your automatic Defender might be a third more. But if you're comparing it to a manual sand filter, which 9 out of 10 times, in all honesty, I'm sorry, I got tongue-tied. In all honesty, you're going to be comparing to a manual sand filter. You're looking at what could be double the cost up front from a standard sand filter. But again, when you're looking at that, when I'm answering that question, that's kind of a loaded question. If it's a new build, what about the piping for backwash? What about the size of the room? What about the backwash holding tank that you may or may not need to hold the backwash water? So there are other variables that are taken into consideration when you're answering that question accurately.
So we have kind of a question from Kyle, so I'll address it. His question is, can you show that last slide with the percentage again? And I'm going to recommend that, Kyle, you download the handout, and that slide is in that deck. You can look at it yourself or share it with your team. So let me know if that will address the question. We have another question, and this will be our last one. Any RMF installed in Alberta, Canada? It would be great to know or see in action.
I can say that I know in Vancouver we do, and I want to say in Alberta we do as well. Whoever's asking that question, I'm assuming that an email of mine is out there, or you can get them my information. And I would know this off the top of my head if you said what's in New York, as you can tell by the way I talk. At Vancouver, I'm not 100% sure. So I would, Alberta, I'm not 100% sure. I would ask you if you could email me. I will get you those references. But I would say yes, we have a facility or two in that neck of the woods.
And that is it. We don't have any more questions at this time. So in order to be conscious of all of your time, I just want to say thank you for joining us, and we hope to see you at our next webinar.
Thanks, everybody.